Hey, hi. Welcome to H&M Technologies online training. This is our last final video of module 5. Till now we have conquered classes, objects, inheritance, polymorphism, encapsulation, and magic methods. But knowing the theory is only half the battle. When you set up into a technical interview or a software engineering role, or when you sit down to build your final project, the interviewer or your professors won't just ask you for definitions. They will ask you to build a system. Yeah, right. That's what we want also. Today we are putting all the puzzle pieces together. We are going to architect a complete financial bank system. We'll design a base blueprint, then protect our financial data, then inherit rights to create a special saving account, and use the magic methods to make it look professional. Open your VS Code, create a brand new file called May project or a bank project.py because we are going to create on bank system, and let's architect some software. First, class design and encapsulation, because every great software system starts with a base blueprint. Our base will be a standard bank account. What does a bank account need? It needs a owner and a balance. But remember our lesson on change the balance, which is protect your bank balance from other users. Which type we are using? Encapsulation method. The encapsulation method can't let anyone manually change the balance. It must be private. Let's write our base class and build a safe way to deposit and withdraw money. For this, I'm creating a base class. Class is a bank account. Remember, our class name should be a Pascal case. Each word should be in a, each word first letter should be a capital letter. Okay, don't forget basics. Okay, then constructing the constructor. The constructor that is defining the under init, and the under init as usual self, then owner, and starting balance is 0. Right, now I'm initializing self dot owner. Now here has come to bank balance. Self dot, how we are going to protect this with the help of encapsulation. When it comes to encapsulation, I need to add a 2 underscore before our parameters. Balance is starting balance. Are we right? This is a encapsulation. Now, to get our encapsulated data, I want a get method. So my get method is, I'm defining get balance self. I'm writing here self dot encapsulated balance. Right, now get is done. Now what to about to add money? I want a set method. Okay, setter. This is a getter and this is a setter. Here I'm defining a setter method is a deposit self. I want amount here. Right, then return. No, instead of just return, I'm picking this as a if amount is greater than 0, then self dot balance, which is our encapsulated balance, add amount. Okay, then print formatted output deposited rupees and the amount. Right, and along with the new balance is rupees. self dot our remaining balance, which is an encapsulated balance, right? And a left situation, that is amount is less than equal to 0. In the situation I want to print withdrawal failed because amount must be greater than 0, or else self dot underscore balance is or else I'm printing, if it is a amount is withdrawal, then I'm printing withdrawal amount, withdrawal rupees of amount, and the new balance, the remaining new balance is self dot balance, encapsulated balance. This is our getter and setter. Now let's test the code. To test, I am printing, see the output terminal, I just print a testing base amount, and my amount is bank account. Here in bank account owner name Arjun, and the starting balance I can give 20,000. Okay, this is what I am giving. Now my account dot I am depositing extra 500 rupees. See the output terminal, deposited a 500, then the new balance is 20,500, because the starting balance we give 20,000. If I give this 2,000, then the amount is 2,500. Okay, so basically I'm giving 5,000 as a starting balance, then the deposited amount is a 500. You can see the changes in a output terminal. Okay, that is a 500. If I change this into 300, then the deposited amount is a 300, new balance is a 5,300. Right, try to invalid one. Invalid one is like if I try to deposit minus 300, see the output, withdrawal failed, amount must be greater than 0. Okay, let's withdraw the amount. So to withdraw, here I'm trying to withdraw, but it's saying no object has no attribute withdraw, because we need to add withdraw object. So here you can see a setter method is was set for deposit. Now we want to set another setter method for deposit. Okay, let's make this. Okay, for this I'm defining function which is a withdraw self and amount, and then if amount is greater than self dot or balance, encapsulated balance, in this case print. If a withdrawal balance is greater than actual balance, then I am printing withdrawal failed, because amount withdrawal amount is greater than the actual present balance. Now in this case withdrawal failed, then it is insufficient funds in account. With insufficient funds, I am printing the balance also, remaining balance is in rupees. Else if the amount, withdrawal amount is the entire unintentionally 0 or less than 0, in the situations I am printing withdrawal failed. Okay, amount must be greater than 0. Okay, finally else self dot balance is a deposited or a withdrawal minus withdrawal. Now done. Now let's see deposit and withdrawal. My amount dot deposit, here I'm depositing 500, then the amount is 500. Then my amount dot deposit. If I give 0, then withdrawal, it's showing a withdrawal. But I want this as a see if I try to deposit a 0 on balance, then it's showing in deposit failed, amount must be greater than 0. Now let's try to add a amount, or we're done adding, then now withdrawing. So try to withdraw amount. I'm withdrawing 300. Then see, withdraw 300, new balance is 5200. Before that account balance is 5500. Now after withdrawing, remaining balance is 5200. Let's see my amount dot. I'll do deposit insufficient funds. If I give how much I am having in a account, 5200. Now I'm trying to withdraw 6000. See the output already. Yeah, 6000 I try to withdraw. 6000. Withdraw failed, insufficient funds. Balance is 5200. With the help of setter and getter, we can deposit, we can withdraw amount, and we can also get our protected balance, which is underscore balance. Underscore balance is encapsulated. We can't directly access the encapsulated data. So that's why we created a method for that getter method and setter method too. This is a professional class design. We can build a system that is secure and reusable, and it is also easy to read, right? So congratulations, you have officially mastered the core of object-oriented programming. You can now model real-world problems in Python. This concept will help you throughout your career, whether you are building a backend API, designing machine learning models, or automating infrastructure, anything. Okay. In module 6, we'll switch gears to exception handling and file handling, learning how to make our programs bulletproof against errors, and how to save our data permanently to files. Let's see there. Now we have practice questions. Adding a class which is a checking account to your file, and it should be inherit from a bank account, and give it a unique attribute called overdraft limit. Example 500 or anything in any amount. Override the withdraw method in a checking account. It should allow the user to withdraw money even if it drops their balance below 0, as long as it doesn't exist the overdraft limit. And then test it by creating a check account and withdrawing more money than you have. See the output, whether it is an insufficient balance or any other error you gave. Okay, thank you for choosing H&M Technologies online training. Happy coding. Bye bye.